Hello and welcome back to Mr. Powers Teaches Algebra. Hey, today I just want to talk to you really quick about what a one-to-one function is. If you recall very quickly, we kind of boiled a one-to-one function down, at least for our purposes in algebra, and the Cartesian plane as to if we, for every x value, it gets assigned one and only one y value. And we had a vertical line test, right? So a function was, if I had a function here in green, like this or whatever, that's a function as long as any vertical line crosses my graph in only one spot, because that vertical line represents all the x value, where an x value can be. And if it crosses our graph in only one spot, it only has one y value in our function. So every x is assigned one and only one y. So a one-to-one function is going to be extra. Okay, it has to have this be true because it is a function, but also another condition here. And so what's that condition? It's right here. In this, I'm going to give you some language here you might not care for, but I'll boil it down. I like this language. I don't know. But anyway, a function f is from a to b. In other words, we're taking elements from a, so those are x values, and we're mapping them to b, so we're getting points. And those are our y values. Is one-to-one if there's two different x values, and we take the function of those. So f of x1 equals f of x2. If that's true, that means that we started with the same x values. All right. Or like this makes it a little bit easier, I think. If we start with different x values, we're going to get different y values. Here, this is kind of saying if we start with the same y values, that means we started with the same x values. What does that really mean, boiled down to us in algebra, when we're just concerned about x and y's and functions like quadratic functions and rational functions, stuff like that? It really boils down to this, what we got here in purple. That is, for any y value in our range, there's at most one x value in our domain, such that f of x equals y, or xy is a point in our graph. So in other words, for this time, it's kind of like the other way around. For every y value, it's only mapped to one x value. And so we can use, instead of a vertical line, a horizontal line test if we want. If we're looking at these graphically, we would use a horizontal line to see if we indeed are dealing with a one-to-one function. So here's a function. It's defined right here, 2/3 times the quantity x minus 3 squared minus 2. And I have a horizontal line here. Right now it says y equals -12, and it crosses my function, which is in blue, in one spot. And I can swipe it up all the way around, and I only cross in one spot. So it is a one-to-one function. So this is our horizontal line test. It's very similar to the vertical line test. If a horizontal line can only cross at one spot on our function, on our graph, then we have a one-to-one function. If it crosses anywhere in more than one spot, no good. And no. So here, let's take a look at one of those examples. Right here. So let's say I have a nice easy equation, y equals x squared. Then almost everywhere, a horizontal line is going to cross in more than one spot. Say, for instance, a y equals 12. So when y is 12, there's two values for x. There's -3.46, or around there. And here, let's pick another one, like nice value here. There we go. So we got -2, 4 and 2, 4. So there's the same y value, doesn't imply the same x value. So this is not a one-to-one function. All right, so there you go. That's it. Why talk about these? Well, because in our next lesson, or kind of we're reviewing, is we're getting into inverses. So we're doing inverses. And for a function to have an inverse, like say for this one, this is a function, its inverse will have to also be a function. We kind of worry about that. And so if it's not one-to-one, then it won't have an inverse function. And that's why we're going to talk about this one-to-one stuff. At least just mess with it for now. So that's it for this video. Until next time, enjoy doing math.